Okay, today we are going to talk about drag. Now drag, or air resistance, is quite difficult to explain, especially when you're not in school with a teacher doing practicals. So I'm going to try and show you what's going on through some diagrams. Now we've got to think about air as being made up of particles. So in my model, my abstract idea is that these are air particles that you've got to move through. Now I'm going to draw a pretty old-fashioned looking car. So that car is going to move through those particles. Okay, that will cause friction between the air particles and the car, and therefore that will cause drag. So that car is going to move through those particles. This streamlined car, or aerodynamic car, is going to move through less particles. So it collides with less particles, so therefore the drag is less. It's going to drive through and hit, let's say, 10 particles. This one here is driving through, in my model, 5 groups of 5, so that's moving through. It's got to shift through 25 particles of air to get through. This more streamlined model, same force applied by the engine, has got to move through less air, 5 times 2, so that means it's moving through 10 particles. Okay, so let's have another example. Let's go for someone high board diving. So we got a guy at the top of a 5-meter board, and he's not quite sure how to enter the water. He's a little bit confused. He's thinking, okay, option 1, belly flop. Now, anyone that's belly flopped in their life knows that it's painful. It's painful because there's a lot of water resistance. The water is resisting you moving through it. So that guy there doing this belly flop is going to have to try and shift through all of that water. So that water is in his way, causing resistance. That's going to be ouch. Now the other option is a normal dive, sort of streamlined body, so you're leading with your hands, punching through the surface of the water, then your head, then your shoulders, then the rest of your body. It's much more streamlined, so it moves through less particles of water and therefore less drag. Okay, another example, fish in the sea. Now let's say this fish can produce 10 newtons of force with his tail to move forward. Okay, but the shape of it isn't very streamlined, so maybe there is 7 newtons of resistance or drag with that fish trying to move through fluid of water. The resultant force, the overall force that wins, is moving forward at 3 newtons. So let's go for a completely different type of fish. Let's go for a barracuda or something like that, streamlined, missile shaped. Now this fish, let's say, can produce the same amount of force, 10 newtons of forward thrust, and it has less drag because it's more streamlined. It's only got 3 newtons of drag, and therefore moves forward with a force of, moves forward with a force of 7 newtons for the same push. Move through with more force, therefore a better predator. So things like sharks and barracudas, good predators in real life. Now here's a free app you can get on App Store. It's quite good to show you what's going on. So again, it's abstract, this idea about particles and air flowing. It's difficult to show you, so here's another model to do that. Now there's a flow of particles, and I'm just going to draw an object, and this way the particles are moving past the stationary object. So you can see how that movement, that speed of those particles bumps into the object and then loses some of its speed. Whereas if you have a more streamlined shape, if this is the bow of a boat, you allow the particles to move around it without losing their speed, without having to transfer their energy to the object. Again, fast car, you can see where the swirls are, you can see where the car cuts through the air. And again, if those particles are moving fast quickly, it means they haven't transferred their energy to the vehicle, and so therefore they haven't slowed down. They do this with wind tunnels, they do this with smoke to check the streamlined nature of certain vehicles. They do this in the model phase when they design any new supercar. Okay, a really unaerodynamic car, and you can see how that smoke will bash into, the particles slow down, therefore they must be transferring that energy to the vehicle, therefore they must be slowing that down too. So really, an object moving through a fluid needs to be streamlined or try to hit as little particles as possible when moving through it. Hope you enjoyed the video. Hope it was useful for you. I know it's a really difficult concept to try and understand, but do your best. Check out some of my other videos, they might explain some more stuff too. Peace.